So the warm-up is a review of what we did yesterday. We graphed two equations on the same coordinate plane. Wherever they intersected, that point was a solution to both of those equations. Remember, we called two or more equations is called a system of equations. Right? So for this first example right here, we start with the y-intercept, which is the -4. So we put a point at -4. And the slope is 3 over 1. So that's rise 3, run 1 in the positive direction. So we go up 3 over 1 for a while until we form our line. And then for the second line, we do the same thing. Wherever they intersect is their solution. So the y-intercept here is 2. The slope is, there's no number written there, but we know it's what? 1. Yeah, 1 over 1, right? So the rise is up 1 over 1, and we're just going to do that until it intersects the other line, which is here. Okay? And so whatever the coordinates are for that point is our solution. So what are the coordinates there? 3, 5. Okay? You don't need to check your answer. I'm not going to require you to do that, but if you wanted to, because it's good to know how, you would put 3 in for the x's, 5 in for the y's, and do the math and see if it checks out. It should check out for which of them? Both of them, right? Because it's a solution to both of them at the same time. For the second problem, real quickly, this y-intercept is 2. The slope is -1 over 1, so that means you go down 1, right 1 for a while in both directions. Either down 1, right 1, or up 1, left 1. Get you the same line. And then for the second one, the y-intercept is -1. The slope is -4 over 1. So if I go down 4 over 1, well, here's the problem. If I keep doing that, I'm not going to intersect on this graph. So what I should do then is go in the other direction. So instead of going down 4 over 1, I can go up 4, left 1. So back to my y-intercept here, I'm going to go up 4, left 1, and that gets me intersecting that line right there. And those coordinates are -1 and 3. Okay, so who got both of those correct? All right, perfect. So let's talk about this problem. And before we talk about this problem, I just have to tell you, I did not write this problem. Are you paying attention to the problem?
Yes.
Nobody runs 1 mile per hour. No, nobody even walks 1 mile per hour unless they're just stopping for 10 minutes at a time. Okay? But anyway, so it's not realistic. These people, they weren't trying. They just wanted a math problem written about them. So Eric has already ran 5 miles and is continuing to run at a pace of 1 running. It's not even walking. It's not even crawling. But it might be crawling. It might be crawling. He's running at a pace of 1 mile per hour. So we need to write an equation to represent that information. Remember, we want y equals mx plus b form. And b is the y-intercept. This is the beginning point before we started tracking the data or the information. And it's 5, right? So he started, he ran 5, and now we're talking about what comes next after that. So b is 5. And m is just the 1, right? Because it's 1 mile per hour. Nope, you don't have to put the 1. So the m is 1 over 1, 1 mile per hour. And then Jess is not doing much better. She's run 2 miles and is continuing to run at a pace of 2 miles per hour, running, quote unquote, air quotes. Yeah, no, still kind of just not trying. 2x plus 2. Now it's 2 in both spots, but this 2 right here, is that the 2 miles she already ran or the 2 miles per hour? 2 miles she already ran, right? And this is the 2 miles per hour. All right, so then we go to our graph. The number of miles depends on time, right? So this is miles, this is time, or hours, which is in hours. So for y equals x plus 5, we start at 5 and go up to over 1 for a while. Oh, it's just 1. You're right. I got the wrong equation. Thank you. So just go to your happy place because this takes forever to do 1 over 1. Yeah, that works too. And then the next one starts at 2, and it goes up 2 over 1, and I'll do that until they intersect, which is right there. Yeah, so that point is 3, 8. Which of those is the answer to our question? The 3, right? It took them 3 hours to run 8 miles.
No, it took 3 hours to get the same amount.
To get the same, which was 8. Yeah. So 3 hours to run the same amount of miles, which is 8 miles. All right, so that is the practice problems that went with our lesson yesterday, which we used for a warm-up. What we're doing today is still solving a system of equations, but we're not going to do it with graphs. We're going to do it with algebra. Yes, with math. But our answers will look the same. They'll look like points, right, ordered pairs. So we're going to do 2 quick examples, and then I will go straight to the practice problems. It's not going to take very long today. Tell us how you really feel. Someone was yawning. Was that you? Or I was like, tell us how you really feel. All right, so this system is, so yesterday's method was graphing. Today's method is substitution. So obviously somewhere along the way we're going to be substituting something for something. But let me just give you some context of why we're even learning this method. And you don't have to write down what I'm about to write down. I just want your ears. Yesterday we talked about this basic kind of equation, right? That's one equation, has one variable. What would you do to solve? Subtract 5 from both sides, and you'd get x equals 8, right? Easy. That's one number, one solution. But then yesterday we've been talking about, well, what if you have an equation that's not x plus 5, but what if it's x plus 5y equals 13? Well, you couldn't really solve now because there's too many variables. You would need to know something to plug in for either the x or y in order to solve for the other one. So what happens is when you have an equation with 2 variables, you need more information to solve for them. And what happens when you have 2 variables is you need at least 2 equations to solve. When you have 3 variables like x, y, and z, you would need 3 equations to solve, and so forth and so on. And then you get really big things, which is why you learned about matrices. Do you remember learning matrices before? So people in business or computer graphics or something, when there's lots of things that are changing and they have a variable representing each of those things, they'll set up a matrix to solve for that information. Because by hand, 2 by hand is okay. 3 variables by hand gets a little bit scary, and anything more than that, you just want to go to your computer, because that's what computers are good for. So what we're doing today is eliminating one of those variables so that there's only one in the equation instead of 2. And we're going to do that by substituting. So here's how that will look. Okay, there we go. Step 1 is you're going to solve one of your equations for either variable. So I have 2 equations here in this first example. And you want to just try and think critically for a moment and try and pick one of the equations. When you're looking at it, you want to pick the variable that's easiest to solve for. Like in the first equation, to my mind, I think y is the easiest one to solve for, because you just have to move that 2x over and you're done. In the second equation, which do you think is the easier variable to solve for? X, right? Because you just move that 2y over. If you were to try to solve for y here, you would eventually have to divide by this -2, which would cause fractions, and it would be ugly. So you want to try and think critically for a moment for the one that's easiest to do. And it does not matter where you start. So which equation do you want me to start with, 1 or 2? Second one? Okay. So on the second one, we said it's easier to solve for x. So here's what we're going to do for step 1 on this problem. Solve the second equation for x. Okay, and how do I do that? What do I do to both sides? So I have this second equation. I want to solve for x, which means get it by itself. What do I do? To both sides, right? We do the opposite, which is add to both sides. So x equals 6 plus 2y. Notice I haven't really found a value for x. I've just rewritten this and said that x equals all of this. So x equals all of this. So what we do next, step 2, substitute that expression. The expression means the 6 plus 2y from step 1 into the other equation. So we used equation 2 for this. We're going to take it and plug it into the first equation for x. Right? So right here I've said that x is equivalent to 6x plus 2y. Those are interchangeable. So then in the first equation where I see the x, I'm going to replace it with all of the 6 plus 2y. So that will look like this. I have 2 times x, but now instead of x I have this expression, and then plus y equals 7. So now I have one equation, and there's only one variable there. There's just y. There's no more x's. So now we can actually solve this for y. What am I going to do with this 2 right here? First, distribute. That's right. So that gives me 12 plus 4y plus y equals 7. What can I combine? How do those y's combine? What does that give me? 5 y's, right? So I've got 12 plus 5y equals 7. What do I do next? Absolutely. Subtract 12 from both sides. It gives me 5y equals 5. And then what? Divide by 5. Divide both sides by 5 gives you y equals 1. So I subtracted 12 from both sides and then divided by 5.
Subtract 12. Yeah,
Oh, negative 5 right here? Okay, thank you. Okay, so negative 1.
That's what you're confused. I'm like, how did you get minus 2? Minus 12.
Okay, thank you. Thank you for pointing that out, because that would mess up our next answer if I got that wrong. All right, so we got y equals negative 1. That's a beautiful thing, but remember our answers are pair, like ordered pairs. It's a point. So I need a y and I need an x. So then, we just did step 3. We solved that equation. Step 4, substitute the solution from step 3. That's this, y equals negative 1, into either of the original equations to find the other variable. And the reason why you can do either one is because it's a solution to both of them. So it works either way. Which one do you want, the first or second equation? Second? Okay. So I'm going to take y equals negative 1 and plug that into the second equation. So I've got x minus 2 times y, but now y is negative 1. What's negative 2 times negative 1? 2, and then subtract 2 from both sides. X is 4. And then the very last step 5 is write the solution as an ordered pair. So here's my x, there's my y as an ordered pair. It is 4 comma negative 1 with parentheses. Right? So you take a moment and try that next example. Again. Step 1, solve one of the equations for either variable. Which equation you want me to do? Which would you like? The bottom one? Okay. And the bottom one is easier to solve for x or for y? And the bottom one? Right. For x, right? The first one is easier to solve for y. We're going to do the bottom one, so that's easier to solve for x. So to solve for x, I subtract 3y from both sides, and I get x equals 9 minus 3y. So then I take that 9 minus 3y, and I plug it into the other equation for x. So that gives me negative 2, and some of you, we're not including the negative in front, so be careful about that. It messes up the whole rest of the problem. So it's negative 2 times whatever x is, which is now 9 minus 3y, plus y equals negative 11. So we distribute that 2, which has a negative in front. So when you do your distributive property, that negative comes along for the ride. Okay, distribute, distribute. So negative 2 times 9 is negative 18. Negative 2 times negative 3y is positive 6y, plus y equals negative 11. We combine the y's, that gives me 7y, plus negative 18 equals negative 11. So we're trying to get that y by itself. So notice that that's the point of the substitution. Now I only have one variable to solve for. I can do that. I can't do it when there's 2 variables in the equation. do the opposite of 18 to both sides, or sorry, the opposite of negative 18. 7y equals 7, divide by 7. Y equals 1, which is great, but we also need x. So I take that 1 and I plug it into which of those other equations? First one? Does it have to be the first one? Nope, it can be either one. So we'll do the first one. So going back to the first one, I've got negative 2x plus y, which we now know is 1, equals negative 11. Subtract 1 from both sides. Negative 2x equals negative 12, divide by negative 2. X equals 6. Write your answer as an ordered pair. 6, 1. 6, 1, and done. All right. So that is your lesson for today. Your practice problems are a maze